and you can see that artists were being inspired by sunsets that were caused by a volcanic eruption they probably didn't know had ever happened. Now, Krakatoa was not the only volcano whose effects were felt globally. I mean, there have been others in recorded history. Laki is just one example in Iceland. Okay, spectacular volcano. Now, this is not a particularly large volcano as far as these things go. Laki is what's known as a fissure eruption. Okay, in other words, a crack opens up in the ground and lava flows out. So instead of getting sort of one gigantic cone-shaped volcano, you get sort of what's called a rampart. It's like a wall, a long wall. But the amount of lava that came out of this was absolutely extraordinary, carrying with it ash and, most importantly, gases, which had profound effects over Europe. The effects of the 1783 eruption, here are just some of them. There were 20,000 deaths in England. This happened in Iceland. 21% of the people, 80% of the sheep, 50% of the cattle and horses in Iceland died because of this one eruption. Unusually warm summers, it caused unusually cold winters. The haze was so thick that ships stayed in port as the sun was described as blood-colored. Droughts, hails, all blamed for rising poverty across Europe. Again, not just in Iceland. That was the single eruption in a place that most people had never heard of. It also marks, I think, an important point in the study of volcanoes, in the study of volcanology, because at the same time that this was erupting, and these effects were being felt all across Europe, an American diplomat who was in Paris at the time wrote this: "The cause of this universal fog is not yet ascertained, or whether it was the vast quantity of smoke long continuing to issue during the summer from Iceland." Now, this is really extraordinary. This is 1783, and this is the first recorded time that anybody made a direct connection between a specific volcano and global climate. I mean, people were aware that a local eruption can affect local weather. But this was the first time, to my knowledge, that anybody put those two together. He was putting global climate with something that he had heard was going on in Iceland, and I think that was pretty extraordinary. Now, American diplomats not necessarily being known for their geological expertise, this may be a little strange to you, but this was no ordinary diplomat. Who are we talking?
Benjamin Franklin.
Benjamin Franklin. Exactly. There he is. Okay. Who was in France to settle our war debts. And I don't know if we had any money for him, but he was trying to do that. But anyway, so anyway, that was the Laki eruption. And now that brings us to the big one. This is it. This is the #1 largest volcanic eruption in all of recorded history, Mount Tambora in Indonesia, 1815. Now, just to give you a sense of the scale of this eruption, okay, it erupted 1,000 cubic kilometers of material. So I want you to imagine just for a moment what 1 cubic kilometer looks like. So picture a square on the ground, 1 kilometer on the side. That's pretty big. Then the cube extends 1 kilometer up into the air. So that's 1 cubic kilometer. Fill that with material, okay, like rock from the inside of this volcano, okay? That's 1 cubic kilometer. This erupted 1,000 of those in a single eruption. And for scale, Mount St. Helens, which was like a real big deal in the United States, less than 1 cubic kilometer. So this is more than 1,000 times more material than ever came out of Mount St. Helens. So that's just for scale before we even get started. Okay, so Tambora erupts in 1815, emits 1,000 cubic kilometers of material, and 1816 is known throughout the world as the year without summer. Why? Well, all of this ash goes up into the air, it blocks out the sun. It literally blocks out the sun, and crops need the sunlight, they're getting less of it, crops die. This was a real problem. There were places that were still covered in snow in June that shouldn't have been. The snow line went through Boston in the middle of June during this year, okay, just to give you a sense of what was going on. Lord Byron wrote in a poem that we'll get to later, "Morn came and went and came and brought no day." I mean, it literally blocked out the sun. And this is a volcano in Indonesia, and this is being written in Europe. This is a true global impact. This is a painting by Henry Williams. English soldiers putting down a riot in 1816, 1 year after the Tambora eruption. And why were they rioting? This was a food riot, okay? Because crops had been failing across Europe. And this was not the only one. There were a series of major food riots throughout Europe, all because a volcano on the other side of the world erupted and the crops failed in Europe. Okay? This is from the newspaper in 1816 describing the riot. And there you see, "No person to be prosecuted for anything that has been done to the present time, provided that every man immediately returns peaceably to his home. I think that was probably wishful thinking, but, and again, a dramatic effect, not just on the painting itself, obviously, but we're talking about history. History, the course of history changed by a volcano on the other side of the planet. Okay, we understand that volcanoes affect locally. We're talking globally here. This is from the poem Darkness by Lord Byron, who wrote this in 1816. I had a dream which was not at all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. Okay? John Keats wrote a number of years after this, I believe in 1819. He wrote a poem called To Autumn, and it was intended to celebrate the terrible summer and failed harvest of 1816 that led at last, in 1819, to a good summer, a full harvest, and a beautiful autumn. Look at that. Look at those ages, those years. 1819. That's about right. Okay? When there's a major volcanic eruption, big time, anywhere in the world, 3 to 4 years is what you can expect. Global temperatures to drop maybe between 2 and 4 degrees Celsius, and these effects will last maybe anywhere from 2 to 5 years, somewhere in that neighborhood. It happened with Mount Pinatubo in the Philippines in 1991. It happened in Krakatoa in 1883. It certainly happened to a major extent during this eruption. And that brings us to Lake Geneva in Switzerland. Now, in 1816, Lord Byron, who had a summer home in Lake Geneva, and I think we can all be very jealous of that, was bringing some of his writer friends and some of their family members to Lake Geneva for the summer. And they were planning on going there and spending some time on the lake, I imagine, and spending some time outside. I think it's lovely. But on the way there, they were met by something very strange. And rather than have summer greet them, what they found was sort of the opposite. This is what they wrote on their way to Lake Geneva in 1816. The thunderstorms that visit us are grander and more terrific than I have seen before. The spring was unusually late, and indeed the cold was excessive, and the clouds poured forth large flakes of snow, thick and fast. This is what was greeting them on the way to their summer on Lake Geneva. And so they couldn't go outside. Okay, they couldn't go outside. So basically, they were stuck inside during this horrible, horrible cold weather, and they did what I assume most writers would do during this time. They told stories. And so every day they'd have a different person tell a story, and they would sort of go around, and every day it was somebody's turn to give a story. And the wife of one of the writers that was there came up with a story, and that story was inspired by the cold around them. Okay, and that story later became a book, and you can see throughout this book the inspiration that came from the cold that was everywhere around them. And so here are some excerpts from that. This is the monster that is emerging in this book. That came from this. The desert mountains and dreary glaciers are my refuge. I have wandered here many days. The caves of ice, which I do not fear, are a dwelling to me. I seek the everlasting ices of the north, where you will feel the misery of cold and frost. Does this sound like something that you would write while frolicking on the beach in Lake Geneva? I mean, this was clearly on their mind. Immense and rugged mountains of ice, often barred by passage. A most violent and terrible thunderstorm, and thunder burst at once with frightful loudness from various quarters of the heavens. Vivid flashes of lightning dazzled my eyes, illuminating the lake, making it appear like a vast sheet of fire. Again, it's not just the cold, but extraordinary weather. In particular, lightning typically follows these major volcanic eruptions, okay? Dust in the atmosphere tends to build up static charge, and it tends to produce lightning that is even greater to go along with the sunsets, okay, that are there. So, clearly, the story that emerged from this summer, summer, if you will, in Lake Geneva, was inspired by a volcano on the other side of the planet, and not one person in that house had any idea that the cold around them was caused by this volcano on the other side of the world. And that the person, are you with me here? Who's this person I'm talking about?
Mary Shelley.
This is Mary Shelley, and she had written Frankenstein. Okay? So thank you very much. That's all. Some time, so if people want to ask questions either about this or about volcanoes or earthquakes, which actually I'll be talking about tomorrow, but if you have any questions about anything, just shout it out.
20,000 people died in England after the accident.
Yeah.
What would they die from?
Most of that was from famine, actually. Massive lost crops during that time, I believe. Yeah, that's what all the riots were about. In the back.
Do you remember a couple of years ago, maybe, there was a volcano that disrupted air travel all across Europe?
Yeah. Agia Fialaioko, yes.
What do you want?
It was called Agia Fialaioko.
So it was maybe a week and a half, that it's problematic,
Mm-hmm.
right? So I guess my question is, should we assume that however many years ago that was, and I don't know, was it so much less intense and less severe that it was cleared up enough within a week to allow for that which clearly affected these?
Well, I thought you were going to ask if it affected air traffic, but no. Well, the immediate effect would have been short-lived. As soon as the volcano stops producing ash, you're going to stop feeling covered in ash. But the volcano will put ash up in the atmosphere that will linger. You won't see it. So the ash that caused the famines throughout Europe, that wasn't ash that people could see. We're talking about a slight decrease in the amount of sunlight coming through. So what was affecting northwestern Europe during that time of the Icelandic eruption was the ash coming through in great amounts. Although in most of Europe they couldn't see it. In most of it, it was just at that level where they were concerned about air travel. And just on a side note, because I think this is interesting, you remember around that time was when Stanley McChrystal made some comments about the president, and he got fired for saying derogatory things about, well, anyway, to a Rolling Stones interviewer. Now, what I thought was most amazing was how he said all those things directly to a reporter. I thought that was strange, and then I found out why. And the reason was that he had been scheduled for an interview with Rolling Stone, and it was supposed to be a short interview. He'd sit down, do his interview, and that was the end of it. But he got stuck in Spain for like 4 days with this reporter, and they got drunk. So Stanley McChrystal was fired because he was running his mouth because he was stuck in a room with a reporter for 4 days. So that's because of a volcano in Iceland. How's that for a connection? Yeah. Yeah. Oh, well, basically, volcanoes are caused. There are 4 main layers of Earth. We have the crust. Everything that we know, every mountain you've ever climbed, every valley you've ever been in, everything you know is the crust. That's up here. And then you have what's called the mantle, which is a layer of rock that is hot because it's down there. And it can flow just a little bit. It's more, you want to think of it more like a tub of silly putty sort of sliding around slowly, very slowly, than solid rock. And that is the source of magma. So when certain conditions are met, some of that material can melt. And because it's under pressure, it will rise upwards and form volcanoes. So there are certain spots within the mantle, which is a solid, that have the conditions that are just right to allow it to melt. And that's where all volcanism comes from, the very top of this layer called the mantle. And then down in the center, you have the core, which is mostly iron and nickel. It's basically a solid ball of iron and nickel floating inside an ocean of liquid iron and nickel that's molten and convecting and moving all the time. So it's fascinating, and nobody's obviously been anywhere there. We use indirect methods to understand what's in the Earth. So you look at earthquake waves that travel through the Earth, and the way they bend and move and change tells you about the material that it passed through. So it's sort of like looking at the Earth with like an X-ray. You go to the doctor and they send energy through your body and then see what it looks like on the other side. Well, it's the same thing. There's an earthquake, that energy travels through the Earth, and then we wait on the other side and observe it. And how it looks will tell you something about what's in it. So the only reason we really know anything about the interior of the Earth are through indirect methods, things like that. But that's basically what's going on. Yeah?
Can fracking cause earthquakes?
Okay. Sure. All right. Well, let's start at the beginning. An earthquake happens when rocks break. If I took a rock here and snapped it in half, that's technically an earthquake. But that's not an earthquake anybody would care about, right? Because it doesn't release a lot of energy. So first of all, when people ask the question, does it cause earthquakes? I think that the question itself is problematic. What you really want to know is, does it cause large earthquakes? Does it cause damaging earthquakes? So technically, fracking is about breaking rock open. So of course, I mean, you can't do that without causing an earthquake. But those are tiny, those are minor, and those have never caused any problems. The issue arises, okay, it has nothing to do with the fracking wells themselves, but because fracking requires a massive amount of water, and that water comes up contaminated and they don't know what to do with it, they ship that water off somewhere else. They inject it into the ground in what are called injection wells, and they pump all of that water they don't want into very, very, very deep injection wells. Those are the wells that are associated with increased risks of earthquakes. So first of all, whenever somebody says fracking causes earthquakes, it's not the fracking. It's just not. It's the injection of the fracking fluid somewhere else. Okay, so that's just number one. Number two, what happens is you push these fluids into the ground, and ordinarily they don't cause any problems. But a fault, a place where earthquakes happen, are two pieces of rock that are pressed together, and they want to move, but the only thing that's preventing them from moving is friction. So these two pieces of rock are locked together, and they want to slide, but they can't because of the friction between them. So what do you think happens when you push water, when you force it under pressure into a fault? You reduce friction, okay? It's a lubricant. So if there were a fault, if there were a fault, and you didn't know it was there, and you happened to put an injection well in this spot, and you were pumping water into that loaded fault, it was already had pressure, okay? In other words, it doesn't cause earthquakes, it could trigger an earthquake. Do you understand the difference there? The pressure's already there. Then yes, you can do that. A good example, I think, is Ohio. Ohio has 172 injection wells, 172. One of them showed increased signs of earthquakes. So they put these things all over the place. They weren't thinking about earthquakes. And one of them, they noticed right around it, they were increasing earthquakes a lot. And they shut that well down. So fracking doesn't really cause earthquakes. And injection wells only cause earthquakes if you happen to drop it onto a fault and you don't know it's there. Now, that being said, what if we put thousands of more wells in? I mean, wouldn't that probably increase the likelihood of this happening? The largest earthquake so far that's been attributed to fracking, I think like a 5. And that's a real earthquake. But even a 5 is not a particularly damaging earthquake. Nobody died, there was no damage, things like that. But what is the maximum size